Okay, in this video, we're going to fire a cannonball on top of a hill. I will explain how you can work out the range in this video. In the next one, I will give you an example, and the one after that, I will give you a chance to practice. But in this video, I'm just going to briefly explain how you would find out the range here. Okay, so we are on top of a hill, height h here. We're going to fire a cannonball at velocity at velocity a meters per second at an angle of theta. So it doesn't matter what the speed is, what this angle is, or what this height is. We're just going to call it a, theta, and h. Okay. Gravity, we're just going to call it g. So the strength of gravity we're just going to leave it as g. So in this video, I will explain how you can find out the range. So to find out the range here, find out the total flight time for this cannonball. Okay, the way you do that is find out the time it takes to get to the maximum height, and then work out the actual height here. Okay, so you work out the actual height and then add it to this, so that will give you the overall height here. Okay, so the first step is to find out the total flight time. That's what you ultimately want, the total flight time. Once you've got the total flight time, then you can imagine you and your dad sitting in a car and driving along for, let's say the total flight time is, let's just say, 7 seconds. Then you can imagine you and your dad sitting in a car driving at whatever speed this is for 7 seconds. Then that will give us the whole range. But the hard part is finding out the total flight time. So to find out the total flight time, you find out the time it takes to get to the maximum height, and then from that you work out the actual maximum height. The actual maximum height, that will give you the height in meters from here to here. Okay, and then you add it to this height here. That will give you this total height here. Okay, and then you would imagine you standing on top of a building here. Okay, now don't worry about it. Just watch the explanation, and then I will give you an example. And then once you've got the actual height here, imagine you standing on top of a building here and dropping a cannonball off here. How long will it take for the cannonball to fall all the way through here? So that will give you the time it takes for the cannonball to fall all the way down here. That would be the same time as the cannonball traveling like this. So then, well, you would then have the total. You would then have the time it takes for the cannonball to fall from maximum height down to here. Well, get that time and then add it to the time it takes to get to the maximum height. Okay, so here you've got the time it takes to get to the maximum height, and then calculate and then work out the time it takes to free fall all the way down here, and then add the two times together, and then that will give you the total flight time. Okay, well, just watch it through so far. Okay, so hang on. So the first thing to do, break this up into its vertical and horizontal components. So it would look like this. Okay, so you break this bit up into this. So the vertical component would be a sine theta, and the horizontal would be this. Okay, and then you would jump to your velocity time graph. The equation for this line here is given by this. And by the way, this point here is T max, meaning the time it takes to get to maximum height. Okay, and let's imagine we were on a flat ground here. Well, by the time it falls back to Earth again, this point here is this point here. Remember, along here is time. It represents time. So this is as time goes along. So hang on. So you're here. This is time going along. So you are now at the maximum height. Well, the cannonball will be at maximum height here. And then as time goes on here, this will be when it hits the ground. So we can call it T ground, if you like, T ground. Make something up. You're allowed to make it up. So here, and then as time goes along, it will hit the T final, if you like. So we can call it T final. You can make up anything here. T ground, T final, T max, or whatever you like. Okay. So this point here is T final. So this is your T final. This is where it hits the ground. Okay. So anyway, so this is your velocity time graph. It would look like this. This is the equation. Now at the maximum height, the velocity would be 0. So you put 0 into the v here. So put 0 into the v here, and then that equation becomes this, and then blah 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 blah. Work backwards to find out the time. So this t here represents the time it takes to get to the maximum height. Okay, so now that we've got the time, we need to actually know the maximum height. So far we know the time it takes to get to the maximum height. Now we need to know the actual height, which is given in meters. So now we've got the time so far. So to work out the actual height, we would need to work out the area of this thing here. We've got the time it takes to get to the maximum height. So it's a matter of getting this times this and then divided by 2. Okay, so the height here is given by this thing here. Okay, so that's this times the time it takes to get to the maximum height, and then divided by 2. Okay, so basically this thing here it's just the area here. It's just this area here. Okay, so this is the area here. You divide it by 2. Here you've got a fraction within a fraction. It looks really ugly. So we've got to tidy up. So at the moment, let's get this multiplying a fraction. So it's going to get multiplied to the top. But then here you've got a times, remember sine theta is just a number. And then you've got to times it with this number, and then times it with this number. So merge the two a's together. That will give you a squared here. Okay, a squared here. And then sine theta times sine theta will be sine squared theta over g. So this whole fraction here is this bit here, and then you've got to divide it by 2. Okay, you've got to divide it by 2. But then here it's really ugly because you've got a fraction within a fraction. So it looks so ugly. So whenever you have a fraction within a fraction, visualize it like this. You've got this number divided by this number. So imagine it as this number divided by this number. And then when you divide, well, you're dividing a fraction, so it gets multiplied to the bottom. So this becomes this. So the maximum height is now this. Okay. Now so now we've got the actual maximum height. This is not the time it takes to get to the maximum height, but the actual height in meters. So this thing here is the actual height in meters here. Okay. And now you hang on. So now that you've got the actual height in meters, add it to this bit here. That will give you the actual height of the whole thing here. So now we've got the actual height, not the time, the actual height. So now, so let's just call this height here z. Okay, so let z equals the height here. Hang on. So here we've got this height here, which is given by this, and then add it to the h and call the whole thing z. Okay, it just saves me writing this thing out all the time. I'm just going to say, oh, let this whole height here, hang on, let this whole height here be z. Okay, so let that whole height there be z. Now we've got this whole height here, which is now z. Now imagine you standing on top of a building here. So you standing on top of the building, the height is z. So use that h equals gt squared over 2 formula. This should be ingrained inside your mind by now. So z is this, and then so we are really asking how long will it take for the cannonball to free fall from here down to all the way down to here. So you would basically solve this. So z equals this, and then blah 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 blah. Work backwards to find out t. So that will give you the time it takes to get down to here. So what that represents is the time it takes for the cannonball to fall down here. You see, the cannonball falling down here will be the same as the cannonball falling down here. So now that we've got the time, okay, now that we've got the time to get from here down to here, then we can add it to the time it takes to get to the maximum height. So once we jump to this scenario here, we've worked out the time it takes to get we've worked out the time it takes for the cannonball to free fall down to here, okay, and then now add it to the time it takes for the cannonball to get to its maximum height, and then add the two together. Then that will give you the total flight time. Okay, that will give you the total flight time. Now that you know the total flight time, hang on. So hang on. So the time it takes to get to the maximum height here, from here to here, okay, is given by this. This is the time it takes to get to maximum height, and the time it takes to free fall. Then basically you add this and this together. That will give you the total flight time. Now that you know the total flight time, then you can imagine don't worry about this bit. Now that you know the total flight time, remember the total flight time is this bit here, plus this flight time here. So now that you know the total flight time, imagine you and your dad sitting in a car here, driving along at this speed. Remember, this speed here is, what was it? A cos theta. Okay, so this speed here is a cos theta, and then you times the total flight time. Remember, the total flight time is the time it takes to get to maximum height plus the time it takes to get all the way down here. That represents the total flight time, and then get the total flight time times by that a cos theta. Okay, so range equals a cos theta times by the total flight time. Okay, that would be your answer. In the next video, I will give you an example. Here's just a bit vague. So watch the next video. Okay.